function f and g are defined by fx equals to 2x minus 3. X is an element of real numbers. Gx is equals to x squared plus 4x, and x is an element of real numbers. Okay, solve the equation f(x) is equals to 11. So I'm going to substitute f in fx. So that's going to be 2 times 2x minus 3 and equated to 11. That gives us 4x minus 6 minus 3 is equals to 11. That's 4x minus 9 is equals to 11. 4x is equals to 20 and x equals 5. Part 2 is find the range of gx. Okay, so now gx is x squared plus 4x, and x is an element of real numbers. I mean, x can take any value on the number line. Then what would be the range? Okay, now there are two ways of doing it. One is plot the graph and look at the range of the graph. I'm going to start with that. If I'm going to plot the graph, I'm going to first factorize it and get the x-intercept. So I have x-intercept is 0 and the other x-intercept is minus 4. So the graph passes or crosses the x-axis at 0 and minus 4, and the y-intercept is also 0 because there's nothing being added. So the graph will go like this. Now, this would be the minimum value the graph can take. So whatever this value is, let's say if it comes out to be minus 3, we're going to write fx is greater than equals to minus 3. But let's see what we get. Okay, now how do we find this value? This is negative 4 and this is 0. So in between these two, we have negative 2. Now let's see what is the value of y when x is negative 2. This would be negative 2 squared plus 4 times negative 2. So that's going to be 4 plus minus 8. So it's going to be minus 4. So then we're going to say that our range is greater than and equals to minus 4. In fact, it was gx, not fx. So we're going to write gx is greater than equals to minus 4. That's part 2. Part 3, and there's also another way of doing this. That is that you change this into completed square form. Let's see how that would work. Okay, so or what we could do is change it into completed square form. So a square plus 2ab plus b square, and then we do minus b square. So this combined gives us x plus 2 whole square minus 4. So this is gx. And if you sketch the graph again, you know that the turning point is going to be negative 2 comma negative 4. And the graph will look like this. And again, you know that the minimum value that the graph can take is going to be negative 4. Okay, moving on to part 3. Find the set of values of x for which gx is greater than 12. Okay, so it's an inequality question. Gx is x squared plus 4x, and it is greater than 12. That means x squared plus 4x minus 12 will be greater than 0. We can do middle term breaking here. X squared plus 6x minus 2x minus 12 greater than 0. X common, x plus 3, x plus 6, minus 2 common, x plus 6, x minus 2, x plus 6 greater than 0. So looking at only the values of x, you'll get x equals to 2, x equals minus 6. But since it's an inequality question and it says greater than greater than 0, so then we write our final answer like this. X is greater than the bigger number, which is 2, and x is smaller than the smaller number, which is minus 6. Part 4, find the value of constant p for which the equation g(f(x) is equals to p has two equal roots. Two equal roots means b square minus 4ac equals to 0. We know this from the chapter of quadratics. Now, let's solve this here. Part 4. G f x is going to be, in G, we have to substitute fx. So 2x minus 3 whole square plus 4 times 2x minus 3 equals to, where did it go? Is equals to p. Let me double check. G fx is equals to p. So f goes in G. 2x minus 3 whole square plus 4 times 2x minus 3 is equals to p. Looks good. Expand this, a square minus 2ab. So that's going to be 12x plus 9 plus 8x minus 12 minus p is equals to 0. 4x square minus 4x, and this would be minus 3 minus p is equals to 0. This is the quadratic equation that we're getting. Now we have to equate the discriminant to 0. So b squared minus 4ac equals to 0. Solve this and get p. This would be 16 plus sign. 4 times 4 times 3 would be what? 48, and minus minus would be plus. 4 times 4, 16. 16p is equals to 0. 16p is equals to 48 plus 16 goes to the other side, negative 64. And negative 64 divided by 16 is minus 4. So p is coming out to be minus 4. Okay. Next part is state function h is defined by, excuse me, hx is equals to x square plus 4x, where x is greater than equals to k. Okay, now notice that hx is the same as gx. This is the same as gx. So we're back to this, but now we write it in the form of hx. Okay, so hx is defined by that, and now the domain is different. Here the domain was all real values, so we took the entire graph. Now it says that x is greater than equals to a value k, and it is given that h has an inverse. Find the smallest possible value of h. Okay, so if h currently would not have an inverse, if you look at the graph of gx, so this graph will not have an inverse. Why? Because it does not pass the horizontal line test. And what should be the minimum value of x that we take so that this gives us an inverse, so that it passes the horizontal line test? That would be if we just start the graph from here and ignore the left part, then this graph will pass the horizontal line test and then it will have an inverse. So H inverse is only possible when you start the graph from greater than and equals to minus 2. And this should be the value of K. K should be equals to minus 2. All right. Did they ask for the value of K? Find the smallest possible value of K. Yes, it's going to be minus 2. Okay, moving on. Part 6, find an expression of F inverse of X. So, sorry, H inverse of X. So Hx is already x squared plus 4x. Okay, now for its inverse, you will need to make x the subject here. Y is equals to x squared plus 4x. That is not possible unless you change this into completed square form. We did that already. Let's do it again. It's going to be x plus 2 whole square, and What did we add with it? I think it was -4. Yep, this was the completed square form we found out earlier. Okay, now we can change it, make x the subject. So 4 goes to the other side, gets added. We'll have to take square root to get rid of the square, plus minus. This is equals to x plus 2. Sending x to the other 2 to the other side, so -2 here. And we almost have our answer. So h inverse of x will be equals to -2 and a plus sign only and square root of x plus 4. Why did we take this positive sign only? Because the domain of h is greater than equals to k, and what was k? -2. So this is an increasing domain. So our range of h inverse of x need to be increasing as well. As x increases, the range should also increase. So that's why we only choose the positive sign and not the negative sign.